One minute. 1 minute. I wanted to change my shirt because I wanted to wear something else. Okay. Yeah, I'm back. Yeah, I'm not late. Hello, you can hear me. Yeah, that's good. And I have zero viewers. That's good too. So we have this bi-weekly contest, sorry, weekly contest that I'm gonna give now. Okay, this is the best content you can find. This is the best shitty DSS sheet you can find. So pay attention while I solve, while I upload my video. Watch while I upload. Okay. Why is my internet bad all of a sudden? It's just summation. Okay. Will I face penalty for this? What if there are no k distinct elements? What if there are no k distinct elements? At most k elements, right? So yeah. So what do we do? How do we do this? I will just sort. Fuck is this? I'll just add them to set maybe. because complexity doesn't change with set or this, right? So we have fourth question, I hope. Okay, only four questions. Let me read hard one first. You're given an array of nums. A subsequence is stable if it does not contain three consecutive elements with the same parity when the subsequence is read in order. Okay, we should not have same parity three elements. Return the number of stable subsequences. The answer can be too large. Okay, it cannot have three things of same parity, right? It can have two. Okay, it can have two of same parity. So if I maintain all the subsequences that follow this thing, but extending. So what am I doing? Extending the problem. Extending. I'm not able to get with good term with subsequences that follow the restriction additionally have two even at end, one even at end, two odd at end, uh, one odd at end. If I have all these subsequences, okay, if I have all these subsequences, then I can get, I can extend it newly. Now I can extend newly with this thing. Now I can know what all newly can be formed, right? If it is even odd or everything. So let me just write it like this itself. For you people, I'll just write it dp. Uh, so I'll write it even of n with exactly one thing previously, or with exactly zero things too. Okay, e0 of n int n equals to nums dot size of, okay, instead of e0 I'll just make it e3 of n, ends with zero things, ends with one thing, ends with this thing, okay, o3 of n, okay. So we want number of such things, right? Initially let everything be zero, maybe like uh, I think I need not even have this thing. I need not even have like three things, but okay, let me be fine. Let that be fine. I'll write it like this. I'm using one based index. So e of 0 equals to e of 0 of 1 equals to e of 0 of this be 1. Why? There is one subsequence with ending with zero number of even things, right? There is one subsequence ending with zero odd things, right? Okay, so now we have to add all these things. Going on a first impression, I recall you wearing white. I don't think I need this thing. Okay, let me just have this. There was something seen in the air, babe. That summer night, there'll always be another time for us to fall in love. That will never. So now let me just have this. Nums, I'm having element I, right? If I reminded two, else. If I reminded two, if I don't use this I, everything else remains same, right? But if I use this I, what happens? What happens? If I use this I, what happens? O of 1 plus equals to E of 0 plus E of 1 plus E of 2. If O is like one thing, before being 0 even things, oh, 0 even things is wrong. Before being 1 even, before being 2 even is what you can take. Before being 3 even is not possible. Okay. Okay. O of 1 reminder equals to M, where M is 29 plus 7. Okay, now O of 2 plus equals to O of 1, but I should not use the previous, I should only use the previous O of 1. Okay, before changing it. That's why I'm moving it above. Okay, we have to be careful here. And that's how it changes, including that. When you're not including that, whatever existing, we are just adding. That's already there. Even things, whatever it's true, it's true. For all things, also, it's true perfectly. So now again we should do the same thing for even. I need not even think, I can just proceed with the same kind of thing because odd and even are equivalent, right? So if it passes samples, probably it passes everything. So now we have our answer. Now we have to find answer equals to, it either ends with odd or it either ends with even. So I did not care much about this. But then I have to be careful. I have to be adding plus 1 to this. Why? We have an empty sequence, right? That involves only one element that I am adding. Right, whenever it's number of things is exactly one, we have that empty sequence. Whenever here it's true. Okay, these things can be empty. Okay, these things can have zero, totally empty. That's why I'm adding that one. Answer equals to O of 1 plus O of 2 plus E of 1 plus E of 2. Answer reminder equals to M return answer. These are exactly having, this will contain everything, right? Exactly having one thing, exactly having two things. It seems, are we passing? 135, what's the answer? 12. 14. I think, yeah, we are passing. So let me submit this. So we need long, long. I'm sorry for this kind of error. But wait, yeah, I may need long, long. Why? I'm just adding three times, right? Or I can just do this thing. Going on my first impression, I recall you wearing white. There was something sweet in the air, babe. Fuck, again same error. So we get two penalties now. So my ranking may be bad, right? You're given an integer array, nums of size n and a positive integer k, an array capped by value, two penalties. Fuck. Which cost me 10 minutes. You're given an integer array num of size n and positive integer k. The array capped by value x is obtained by replacing every element of nums with minimum of, okay, we're capping it. Each integer, for each integer, determine whether it's possible to choose a subsequence of the array capped by x such that the sum of the chosen elements is exactly k. Okay, once you start capping, is there a subsequence that sum is exactly k? We have to return 0 next below. So if it's possible, then using x equals to I plus 1 and false otherwise. So we want to know if after capping it, what are all the possible sums? Okay. So both n and k are small. Can I brute force? Going on a first impression, I recall you wearing white. So let's say I have before this element I have all the possible summations for all possible case. Once I add this summation, that summation can be once I add this include this value among all subsequences that can be used with capping to elements greater than or equals to that, right? So I will update their summations, okay? But then it will be when I have this, I'm updating nums type of summations that cannot be correct. No, 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 no. I cannot use this among everything, right? I cannot use that for everything. When I have that, okay, how to solve this? This being more difficult than hard. Is it LeetCode's way of giving third one more difficult than fourth one? So how to think? So we have knapsack to find all possible subsequences, right? And then what do we need? Can we form exactly k is what we need? Can we form exactly k, which means probably we will find for all. Oh, k itself is less than or equals to 400. So if k is less than or equals to 400, let's say for all caput things I'm maintaining, can this be formed less than or equals to, should I use bit set? Does this need me to use bit set, like to do some n into k into k optimization of size n we have to return? So n into k can would n into k n into uh, to k work with bit set? Otherwise, is there an easy solution? Otherwise, I don't think there is an easy solution because like we have many caput things and then we want to form subsequences. Or if I look at them in terms of frequencies, okay. If I look at them in terms of frequencies, it's like if you have all the subsequences still here, so you have ones, you have twos, you have threes, up to so on. Let's say you have x's, x plus ones. So let's say you have all the subsequences till that you form till here. Now, once you have all of them, like k of summations k, you will try to cap all these things and then you will find what all are possible in. Once you cap all of these things, you can just go over all of them. Once you cap all of these things, okay, you have excess of some frequency. If I go over 1x, 2x up to so on until I reach k, I think I'll be fine, right? As number of x's increases, we will reach k sooner, and then we will be fine. So maybe this is enough. Maybe this is like k log k. Maybe this is like k by x complexity, right? Summation over k by x is what I do over all x. Additional complexity. I don't think this is too much. Okay. So what do I do? I will have my dp of n, which is like just like knapsack thing. Okay. Dp of k, where all the things that are possible so far. And then I will have my frequency array. Okay. And then I will also have sub of k plus 1, let's say. So first I'll just form the sequences, okay? Frequencies, okay? Going on my first impression, I recall you wearing white. There was something sweet in the air then. Now I'll maintain. I will form the suffix array, okay? Suffix array is to know how many of these things are, okay? So now we are trying to form our dp, which is dp of 0. When nothing is involved, this is the only possible thing. So now when I am at, when I am, okay, zeros are not present, right? Okay. Frequencies of n plus 1, because we have n plus 1 distinct things, right? So when I am here using previous things, how many can you form k? So for int, I will use jxs, let's say j equals to 0. Okay, j less than or equals to sub of I, because sub of I is the number of things you can use. J plus plus, okay. But I have to use this optimization if I'll keep it x, okay. We have answer to. If x times j greater than k, it's impossible. Let's just say this to be false. We'll just break. But if it is less than or equals to k, now we have to see if dp of k minus x times j is present. Okay, equals to true. We found. Okay, we are done. This is of complexity summation x k by x over all x. That should be fine. Right. But then we have to form the dp2, right? We have to form the dp2. So how do I form the dp now again? So this is just something that uses all the things after that. But now to form the dp, I have to use only these elements, right? I'll just go over each of them. In j equals to 0, j less than or equals to, I'll try to come from using more things because I'm maintaining same DP array, right? So I will try to come from frequency of I, j greater than or equals j greater than 0, j minus minus. So if I use these many things, that will, if, okay, for int sum equals to k, sum greater than or equals to j times x, sum minus minus, because see, for each frequency of thing I'm doing k times. This should be fine because summation of all frequencies is n, right? So n times k should be fine. So for all these things, if dp of s minus j times x is possible, then dp of s is possible. So why am I coming from biggest things first? Why am I coming from biggest things? Because then we will have the previous array. I want to use previous array to find the new array. So I'm coming from biggest things before so that I can use previous array well. Because if I come from smallest, I may update this and then I may use, right. But then I have to do it in reverse way. Okay, I have to do it in reverse way. Even now things are getting updated. Okay. So now we have these sums. Or let's just do this thing. Let's just do this thing. J equals to 0, j plus plus, j equals to 1, j equals to 0, j plus plus, j less than frequency of x. So what am I doing now? This is also x. What am I doing now? I'm trying to do something x times where it allows me to use using all the previous things and using 1x initially, and then using all the previous things and using 1x and then using one more x. So this is just assuming that this assuming you are having x's x up to so on and previous things. So now I'm adding this x and then I'm doing basic knapsack and then I'm adding this x and then I'm doing basic knapsack and up to so on. So that should be fine. What is it not C++ 14? I mean, is it not like C++ big thing? So this should be fine, right? I'm returning for x equals to 3, I'm returning false. But for x equals to 3, if everything is capped by 3, can you form k? You can, right? Why is this going wrong? So this will make sure that j is less than or equals to k by x. So k by x complexity should be fine. Where am I doing wrong now? Everything is fine. Right, I'll just output my DP array and then I'll just check it, okay? Uh, Here I can just output DP array. It's taking longer than I expected, right? So if you see that, initially only 0 is fine. And then using 1, 0, initially using 2, we have both 0. Using 1 only 0 is fine. Using 2 you have both 0 and 1 is fine, is working. Using 3 you have 2. Using 2 comma 3 you can form 2, you can form 3, you can form 5, okay? So using 3, you should be able to find if sub of I is right, you should be able to find everything. So my mistake was in sub of I actually. So let me submit this. So we are done. It's not taking too much time of me. So I'm ending the stream. I hope I have explained it well. Thanks guys, but I cannot make it private right now, public right now, because contest is going on. When will it end? I'm ending it. Maybe I will make it public after when? 58 minutes more? Fuck.